Hello there, my name is Håkan Dalsvik and I work as a senior electronics engineer here at TYRI. Today we're going to take a look inside the TYRI EMC lab and talk a little bit about EMC and why it's so important to consider when we design the electronics used in the TYRI lights. So let's go inside the control room here and take a look. EMC stands for electromagnetic compatibility. And that term means being compliant with the environment that our product exists in. So being compliant is about being able to handle the disturbances that usually exist on a vehicle, and also about us not disturbing any equipment on the vehicle. To regulate how we make sure we are compliant, there are councils like Senelec and ISO that develops standards that gives us information about test setups, limits and parameters that we need to comply with. Our products are sometimes used far away from broadcasting antennas and see poor reception. This is a very good idea to keep quiet during those circumstances, to give the best possibilities for good reception. Lights are also often mounted in clusters very close to receiving antennas. And that is another good reason to keep quiet, because they easily disturb the communication then. So, to demonstrate this a bit, here we have a standard transistor radio, nothing complicated, and 2 car batteries to power the lights. So first I turn on the radio. And here we have pretty good reception of the channel. And then we want some illumination on the vehicle. So we take a light here and we connect that to the battery here. And now you can see what happens if you don't have so good filtering and take so good care of the EMC of your light. Now let's switch to a TYRI light and see what happens. There we go. That's how it should be. Usually what we test here is what kind of emissions a product gives out, and also how immune it is to disturbances around it. Here you can see a spectrum from a competitor light, and this is an emission spectrum of conducted emissions that you see here. You can also see the limit lines and how the signal relates to those limit lines. This is not really a good example of how it should look. So when you measure emissions from a product, you have to make sure that you measure emissions only from your product and not something else around it. So then it's a good idea to put it in some kind of enclosure. So let's step over here and take a look inside our enclosure. So this is our semi-anechoic chamber. And on the walls here you can see absorbers, and those are for absorbing any reflections coming from our product. So we only measure the emissions coming from the product and not something reflected off a wall. Here you can see one of our antennas. It is used for measuring radiated emissions. It can also be rotated, so we measure both horizontal and vertical polarization. So when checking the immunity of a product, we use also antennas to subject our light to radiation. And we use the same chamber for that purpose, so we don't radiate anything out into the environment or disturb anything outside. With antennas we measure emissions and immunity, but those are only the radiated part of it. So we also measure conducted emissions and immunity. And for measuring conducted emissions, we use these artificial networks that you see here. But then we use a shorter cable than this, everything described in the standard. Now we can step outside again and take a look at our measuring receiver and other equipment that we use for EMC measurement. So here you can see our measuring receiver that we use for measuring conducted and radiated emissions. In the same rack you can see a signal generator and 2 amplifiers and a switch network. Those instruments are used for testing radiated immunity. Over here we have another unit or controller with a signal generator and amplifier that we use for testing conducted immunity. We also have a power supply and a unit that controls the antenna, and also the turntable that we have here. This here is a bad boy. This is an ESD simulator that can generate ESD pulses or electrostatic voltage in a controlled manner, all described in the standard. So here you can see our setup for testing vehicle pulse testing. So these instruments are compliant with standards ISO 7637-2 and also standard 16750-2. To summarize a little bit, what we test here is conducted emissions, radiated emissions, conducted immunity and radiated immunity. And we also test vehicle pulses and electrostatic discharge. When it comes to standards, these vary depending on the application where our lights are used. So if you compare like a forklift truck with a forestry harvester, they use different standards for EMC certification. So this was a little how we work with EMC here at TYRI. I hope you liked it and found it useful.